So today we're going to move on and go back to what we were covering before fall break. So we had some review yesterday about congruent triangles and triangle properties. Today we're going to start learning about shortcuts to prove triangles are congruent. So it turns out you don't have to have every single side and every single angle in order to do that. But before we get into that, I just want to remind you of a couple things that we learned about congruent shapes. So if I give you a congruency statement, A, B, C, D is congruent to E, F, G, H, then that tells us some very specific information. We're going to start with the angles. So angle A is in the first position of the first shape. Angle E is in the first position of the second shape. So that means angle A is congruent to angle E. Angle B, the second letter, would be congruent to, so B is the second letter, would be congruent to F, the second letter in the second shape. Then we have angle C, which should be congruent to, yes, angle G. And then we have angle D, the last letter, which should be congruent to, yes, angle H. Okay, so now we're going to look at your sides. So it works the same way. AB is the first two letters, which means we're going to match that up to the first two letters of the second shape. So we're going to have EF. BC would be your next two letters, so the second and third. So we're going to use the second and third, so FG. Your next two letters would be CD, which is the last two letters, which is GH, the last two letters. And then the final piece would be the first letter and the last letter. So first and last, which would be, yes, which would be EH. Perfect. All right, the next thing says CPCTC stands for what? So CPCTC is what actually allows us to do what we just did, and it says that corresponding parts of congruent triangles are congruent. And then the last little thing there, the third angles theorem, just says that if I have two congruent triangles, or I have two triangles, and I know that two of the angles are congruent, then that means the third one would also have to be congruent. That's why it's called the third angles theorem. So the next thing that we need to talk about is steps for proofs. So this part of the chapter is going to start focusing a lot on proofs. So when we look at these proofs, there's some certain steps that we have to do each time. The first step is the given. So we have to write down anything that we were given and the reason would be given. We're going to look for vocabulary. Are there any words in the given information? So like midpoint or bisect, those kind of words are what we're looking for. And we're going to use their definition if it's there. The next one would be reflexive, which we've covered already. So that is, do they share a side or an angle? So if they share a side or an angle, you're going to be expected to mark that, and that will be one of the things that we can use in our proof. The fourth thing you're going to look for is vertical angles. So that's that bow tie. So do you see the bow tie that we can mark? So if you do, then we know that we can use that in a proof because vertical angles are congruent. The next one is your Z angles. So that's where you're given a picture that's like the parallelogram. If it gives you arrowheads, then you're looking for this Z shape, because if you see the Z, then that means these two angles are congruent. At that point, you should be able to say that the triangles are congruent, which we're going to learn about that today. And then if there's any step beyond that, then we're going to use CPCTC. So that's why I wanted you to have this paper kind of as a cheat sheet, so to speak. So you're going to hold on to this one, just keep it for reference as we move through some of these other things we're going to do today. So we're going to go ahead and get started on the other notes at this point.